Okie doke. We're on 12.1. All right, so chapter 12 is basically a little introduction into statistics. All right, so we'll just talk about a couple basic terms that are used in statistics. First is the population. So that is the set containing all of the people or objects whose properties are to be described by the data collector. So for example, you could have, your population could be the whole population of the US, or the whole population of the world, or the whole population of Texas, or something like that. Or it could be like, I don't know, all bottles of Coke that were ever produced, maybe, something like that. And then you have the sample, which is a subset of the population, the ones that you're actually going to study those specific things. So, if our population was, all the people, all the students of Weatherford College, we could have a sample that was just the ones that are in this class. That could be a sample. Or if your population was like all bottles of Coke, then your sample could be like all the ones that are at your local Walmart or something like that, for example. Since you can't, it's usually with having a population, it's hard to look at every single person or every single thing in that whole entire population. Like it would, it would be hard to get every single student to, maybe you wanted to like measure the height. It would be hard to like get every single student to come in so you could actually measure them, right? But you could get a small sample and then you use that to kind of extrapolate to the whole population, basically. And there's a lot of different ways to take a sample. The best way is to do what they call a random sample, which is a sample obtained in such a way that every element of the population has an equal chance of being selected. Random sampling is the best way to get a representative sample. All right. So for example, just taking all the people in this class or something like that, that would just be like a convenient way of taking a sample, but it wouldn't be a random sample. It might not be a very representative sample. All right. We're going to go over how to make a frequency distribution. All right, so basically, let's say that you have a bag of M&Ms and you're going to basically just take each M&M out of the bag one by one and record the color of that M&M. And so that's what this represents here. So you're just taking the M&Ms out of the bag and you're like, okay, brown, brown, yellow, okay. And so we're going to make a table that states how many of each color we have, basically. All right, so we'll start off by just doing like tally marks. Okay, so we have brown, brown, yellow, red, 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 brown, orange, blue, green, blue, brown, yellow, yellow, brown, red, red, brown, 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 green, blue, green, orange, orange, yellow, 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 red, brown, red, brown, orange, green, red, brown, yellow, orange, red, green, yellow, yellow, brown, yellow, orange. Okay, so then I'll write down the actual number. So I actually have 12 brown ones, 10 yellow ones, 9 red ones, 6 orange ones, 3 blue ones, and 5 green ones. Okay, so that's a frequency table or a frequency distribution. And if we wanted to know the total number, I could just add up the frequency column and that would tell me the total number of M&Ms that were in that bag. Okay. Well, depends on what the question is. That's the frequency table. And there's really no other question on there other than that. But like I said, if you wanted to, you could do things with that, like add them up to see how many was the total, number of M&Ms in the bag. And then you could do like, probability, like what's the probability that, if you select one, what's the probability it's brown, and it would be 12 out of whatever the total was, or, but I mean, they didn't ask that in this case, but. And then on the next page, we have a histogram. So it's like a bar graph, sort of. All right, so that's the histogram. So it's showing that there's 12 brown, 10 yellow, 9 red, 6 orange, 3 blue, and 5 green. And then it also is mentioning the frequency polygon, which is not on here yet. So I'm going to draw the frequency polygon. And okay, so what I'm going to do is I'm going to put a dot, like a point, at the middle top of each of these rectangles, as well as one here at the very bottom and at the end. And then I'm going to connect all of those dots, and that's going to make the frequency polygon. All right, so that thing is the frequency polygon. All right, so next we're going to look at a grouped frequency distribution. So the following data represent the time between eruptions in seconds for a random sample of 45 eruptions at the Old Faithful Geyser in Wyoming. Construct a frequency distribution using 670 to 679 as the first class. All right. So when you make one of these things, you want to make all of the classes the same size. All right. And so with something like this, you might need to, or they might ask you, like, what is the class width? So, whoops. The class width. So in this case, so you would just subtract, you can do like basically 680 minus 670. Equals 10. So 10 is the class width in this case. And that would be the same answer if you did 690 minus 680 or 700 minus 690, because they all have the same width. And that's what you want. All right, and then the lower limit of the first class is 670. And the upper limit of the first class is 679. All right. Okay, so I'll go ahead and fill in the tallies. And I'm just going to go column by column. So 728, 730, 726, 698, 721, 722, 700, 720, 729, and then go to the next column, 678, 722, 716, 702, 703, 718, 703, 723, 699, third column, 723, 708, 736, 738, 735, 695, 706, 711, 714, fourth column, 735, 714, 719, 725, 699, 702, 733, 696, 700, last column, 703, 713, 672, 711, 695, and 731, 726, 695, and 718. All right, so then I'll write down the actual number. So that would be 2, 0, 7, 9, 8, 11, 7. And something else to notice is that if you are going to make one of these type of things, notice how they have 670 to 679 and then 680 to 689. You don't want to say 670 to 680 and then 680 to 690. You don't want to do that, because then you're putting, then what would you do if you had the data point of 680 and you've got 680 on one and 680 on the next one? Which one are you going to put it in, right? So you know, when you're constructing it, you want to make sure that you don't do that. You don't do it that way. That's why it's 670, 679. Yes.
Was there supposed to be 9 under the 7.7? Because there's 45 spots and now I'm 44. So I had an extra.
Okay. On which one? Which line? 7 what?
7.7.
Okay. All right. Good. Let's check. Let me check here. Okay. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, you're right. Cool. Okay. Very good. Very good way to check that. All right. All right. Any other questions about that? All right. And also just to point out, you could turn this into like a histogram. And if you were to do that, so make sure you still include a space, even though like the second category has 0 data points in it. But if you were going to do like a graph, like a histograph or anything like that, you still have to include a space for the one, even though it has 0. So it would just be like a blank space with no column on it. All right, so next we're going to look at a stem and leaf plot. So here is an example of a stem and leaf plot. So if I was to, so this is just one way of representing a data set. So if I was to start writing down the data set, I'm not going to write out the whole thing because it's a lot. But if I was to start writing out the data set that is represented by this stem and leaf plot, the smallest number would be 28. And then I've got 38, 38, 38. Now, normally if you were constructing a stem and leaf plot, so this part over here on the left is your stem, and then these over here on the right are your leaves. Normally you would want to also put those little leaves in order from like smallest to largest, which this example doesn't have them listed in smallest to largest, but if you were going to make one, you should. But and then like 33, 39. Okay. And then a bunch of other stuff. Da 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 da. And then at the end we have 75, and then the largest number in the set is 85. Okay. Does that make sense? So this stem and leaf plot is another way of representing a big list of numbers. So the stem is like the tens place, and then the leaves are the ones place. So it's so it's 28, and then it's 38, 38, 38. Oops. 33, 39, 32, 39, 32, 32, 47, 48, 42, 40, 43, 40, 41, 40, 44, 47, 40, 46. All right. Let's see. I think the next, okay, so the next thing I'm going to do is take this small data set right here and turn it into a stem and leaf plot. Okay. So if it didn't make sense yet, maybe this will help. Okay. So my smallest number is 22 and my highest number is 72. So for my stem column, I'm going to go basically 2 through 7, 2, 3, 4, 5, 6, 7. So that's my stem. All right, so my smallest number is 22. So I'm going to put a 2 here on the leaf area. And another thing, sometimes with the stem and leaf plot, like in that last one, they didn't use any commas, but sometimes you might, I think maybe on the homework, they have you use like a comma, and then they may or may not put a space in between. But the next number in your data set is 23, so I put a 3 there. Okay, and that's all the 20s. So then let's look at the 30s. So we have 38, so I'm going to put an 8 here. And that's all the 30s. And then I have 47, so I'm going to put a 7 here, and that's all the 40s. And then for 50, I have a 50, and then I have a 51, so it's going to be 0,1. And then I have 61, so I'm going to have a 1 here, and I have 72, so I'm going to have a 2 here. So there is the stem and leaf plot that represents that list of numbers. Like I said, sometimes you can put a comma or you cannot put a comma. Just sometimes some people use it and some people don't. Yeah. And I think that's the way they do it on the homework is I think they do use commas. I think it'll tell you, or you can look at the example to see. All right. So I think that's the end of 12.1. And then we will move on to 12.2. All right, 12.2 is about measures of central tendency, which is pretty much mean, median, and mode. Also mid-range. So most people are familiar with mean, median, and mode. You may not have heard of mid-range, but mid-range is really easy to calculate as well. So the mean is just another word for average. So you have a data set, or in other words, you have a list of numbers. So to find the mean, you're just going to add them all up and then divide by how many numbers are in the list. That's how you calculate the mean. And then the median is in the very middle of the data set. So to find the median, you first want to put your numbers in order from smallest to largest, and then you want to find the middle. So if there's an odd number of data points or an odd number of numbers in the list, then you'll just find the middle number, and that's it. If there's an even number, then you'll have to take the 2 middle numbers and average those. So in other words, take the 2 middle numbers and add them up and divide by 2. So there's always an equal amount of numbers on either side of the median. And then the mode is the one that has the highest frequency, or the one that's repeated the most number of times. So if nothing's repeated, then you would have no mode. And if multiple things are repeated, then you may have more than one mode, or you might just have one. And we'll see examples of all that. And then the mid-range is just the average of the smallest and largest values. All right. All right, so to find the mean, we're gonna just add these all up and then divide by how many there are. 4 plus 6 plus 1 plus 3 plus 8, and then divide that by 5. And you can put it in your calculator just like that if you want to. So that's going to be 22 over 5, which equals 4.4, I believe. And then for the median, I want to put them in order from smallest to largest. So 1, 3, 4, 6, 8. And then the middle number is 4. So that's the median. And you can see that there are 2 numbers on the left of the 4 and 2 numbers on the right. So there's always the same amount of numbers on either side of the median. So your median in this case is 4. Okay, so just don't forget that you have to put them in order from smallest to largest before you identify the median. And then the mode, in this case, nothing is repeated, so there is no mode. Because yeah, there's nothing that is repeated. So the mode would have to be something, a number that's repeated, and nothing's repeated, so there's no mode. Then 4 would be the mode, So the mid-range, we're going to take the smallest plus the largest, and we're going to average those, so meaning we're going to add them together and then divide by 2. So 1 plus 8 divided by 2, so that's going to be 4.5.
What was the answer on the middle?
4.5. All right, so add these all up. And then divide by 6. So that equals 30 divided by 6, which equals 5. And then I'm going to put them in order from smallest to largest. So 1, 3, 4, 6, 8, 8. Okay, so the middle would be here in between 4 and 6. So we need to average the 4 and the 6. Four plus 6 divided by 2. That's 10 divided by 2, which is 5. Okay, so half of the data set is smaller than 5, the first 3 numbers, and half of the data set is higher than 5, the last 3 numbers. 3 numbers are less, 3 numbers are more. So there's always the same amount of numbers on either side of the median. And then in this case, there are 2 8s and nothing else is repeated, so the mode is 8. And then the mid-range, 1 plus 8 divided by 2. So 9 divided by 2 equals 4.5. Okay. All right, 1 plus 8 plus 4 plus 6 plus 1 plus 3 plus 8 plus 1. And we're going to divide that by 8. And that's going to equal 32 divided by 8, I believe, which equals 4. And then to find the median, I'm going to put these in order from smallest to largest. So I have 1, 1, 1. 3, 4, 6. 8, 8. All right. So here's the middle in between 3 and 4, basically. So I've got to average the 3 and the 4. Median, we'll do 3 plus 4 and divide that by 2. So that's 7 divided by 2, which is 3.5. So half of the data set is smaller than 3.5, and the other half of the data set is bigger than 3.5. All right, and the mode in this case would be what?
So this one has like two modes, like one is living, only like 7 but that's it.
No. So there are situations where you can have 2 modes, but this is not one of them because there's more ones than there are of 8s. So whichever one has the most, that's your mode. So in this case, 1 is the mode. That's right. Yeah. Mm-hmm. And then we'll do the mid-range. So again, that's going to be 1 plus 8 and divide by 2. 9 divided by 2 is 4.5. All right, number 4 is a frequency table. F stands for frequency. All right, so what this frequency table is telling me is that my data set consists of 2 zeros, 3 ones, 1 2, and 2 3s. So when you have a frequency table like this, now this one is, the frequency numbers are relatively small, but you could be almost just as easy even with really large frequency numbers. You know, if I change that to 25 and 35 and all that stuff, it's still, you can still calculate it pretty easily. Because what you're going to do, it's kind of like what we did in 11.8 with the expected value. We're going to multiply across x times the frequency. So 0 times 2 equals 0, 1 times 3 equals 3, 2 times 1 equals 2, and 3 times 2 equals 6. And then we're going to add up we're actually going to add up both of these columns. We're going to add up the frequency column. So when we do that, that's going to equal 8. And then we're also going to add up this x times f column as well. That's going to equal 11. And then the mean equals 11 divided by 8. Which equals 1.375. So it's just kind of a shortcut instead of having to list all of the numbers and then add them up. Because really, like I said, the frequency numbers in this case are small, so it would be relatively easy to just write out the list and then do it like normal. But I also want to show you how you would do it if you had really high frequency numbers. You wouldn't want to write them all out if it was like hundreds of numbers. Okay, so we also want to find the median. And again, I'm going to show you how you could do this even with large frequencies. All right, so we have 8 numbers in this data set. So 8 divided by 2 is 4. So we know that there's an even amount of numbers in our data set. So the median is going to have to be the average of the 2 middle numbers. And there's going to be 4 numbers on either side of the median. So there's going to be 4 numbers in our data set that are smaller than the median. So 0 represents the first and second numbers in our data set, because we have 2 zeros. And then 1 is the third, fourth, and fifth number in the data set. So let's see, and then 2 is going to be the 6th and the 7th number in the data set. Okay. So the median is actually going to be the average of the 4th and the 5th numbers in the data set. So the 4th and the 5th numbers in the data set are both 1. So that means that basically the median is 1. Yes.
So it's not like finding the full median, where you get that number.
I mean, it is, but this is a way to do it without having to list out all the numbers, basically. So like I said, in this case, it would be easy to list out the numbers, but what if your frequencies were a lot higher, then you could use this, but it would be a lot harder to list them out if your frequencies were 20 and 30 and 40 and 50 and things like that,
Well, because when I list out the numbers, I got 25 because I got 2
2 ones in the middle. So 1 plus 1 is 2 divided by 2. Yeah. Mm-hmm. All right. So, okay. How did you tell for the first, second, third, and so on? Okay, so, all right. So what the frequency table is telling me is that my data set consists of 2 zeros and then 3 ones. So like I said, this one's relatively easy to write out. So if I wrote it out, it would be 0, 0, and then 3 ones. So it would be 1, 1, 1, and then 1, 2. So it would be a 2, and then 2 threes. So it would be 3, 3. So, you know, if I wrote my data set out, that's what it would be. And so there you go. So my first number is a 0, my second number is a 0, my third number is a 1, my fourth number is a 1, my fifth number is a 1, and so on. Hopefully that answers your question.
That's easy to do.
Yeah, it is easier, but what if, like I said, what if instead of the frequency being 2, what if the frequency was 25? Then you would have to sit there and write 25 zeros. Or what if it was 2000? I mean, you know, then it would be way harder to write out and you wouldn't want to do that. So that's why I'm showing you this way. And I know it's kind of confusing at first. And we can do another, I can do another example of that in a minute. So let's finish this one though. So the mode in this case would be 1 because it has the highest frequency. And then the mid-range, 0 plus 3 divided by 2. That's 3 divided by 2, which is 1.5. Okay, so on the next problem, I have a frequency histogram this time. So I think what I would do with this is write out a frequency table, and then I would solve it the same way I did the last problem. Okay. All right, so that histogram, so this is telling me that I have 1 5, 3 10s, and I really don't need to include the 15 on this just for calculation purposes. I've got 2 20s and I've got 4 25s. All right. So I'll go ahead and multiply across. X times the frequency. So 5 times 1 equals 5. 10 times 3 equals 30. 20 times 2 equals 40. 25 times 4 equals 100. All right, so I need to add up the frequency column. That adds up to 10. I need to add up this column. And let's see, that's going to add up to 175. So then the mean equals 175 divided by 10. So that's going to equal 17.5. Okay, and then to find my median, so I have a total of 10 divide that by 2, that equals 5. So my median is going to be the average of the 5th and the 6th item. All right, so I have 1 5. So that means the first data item is a 5. And then I have 3 10s. So that means the second, third, and fourth are 10. So where did I get the 10 is because there's 10, I added up the frequency column and that's 10. So that means there's 10 numbers in the list or 10 data points in the data set. And so I'm dividing that in half because the median is the middle. So I basically, since there's 10 items in the list, I know there's basically going to be 5 items that are smaller and 5 items that are higher. So that 5th and that 6th item are my 2 middle items that I have to average. All right, so 5 is the first thing, and then second, third, and fourth things are 10.
Minus,
Second through fourth. And then this is going to be 5th and 6th right here. Okay, and so since both the 5th and the 6th item are 20, the average of 20 and 20 is just 20. You don't really even have to calculate that. 20 plus 20 divided by 2, it's 20. So my median equals 20. And then the mode is the one with the, if you notice in the definition of mode, it says it's the one with the highest frequency. So in this case, that would be 25. And then mid-range. Five plus 25 divided by 2. So that's 30 divided by 2 equals 15. All right, here's a couple more questions about mode. So number 6, what is the mode?
Would it be second, right?
No, the mode is the one that's repeated.
I know, but there's 1 and 8.
Right, so it's just, you don't do anything, you just say it's 1 and 8. You don't do any averaging. And then on number 7, right, no mode. Let me see, let me give you a couple more examples about mode. Let's say we have 2, 2, 3, 3, 5, 5, 5. So in that case, what would be the mode? Right. Okay. Here's another one. What if I have 1, 1, 2, 2, 5, 5, 5, 8, 8, 8. And then what would be the mode?
would be just 5 and 8.
5 and 8. Mhm. Okay. Let's do one more with the frequency table, because I know that's tricky. Okay, let's do that. All right, and let's just focus on the median because that's the tricky one. Okay, so it's telling me that my data set consists of 35 twos, 43s, and 27 fours. Okay, so I really don't think you want to write all these out. And if you do, I'll just make it 35 million. Okay, no, let's not do that. All right. So let's add these up. So that'd be 102, right? Okay, so there's 102. All right, so let's say then 102 divided by 2 equals 51. All right, so that means that there's going to be basically 51 numbers on either side. So I need to average item number 51 and 52 to get my median. So my median is going to equal the average of the 51st and 52nd numbers on the list. Okay, let's see. Should put that down here.
So would it just be 40?
Well, remember the data point, the numbers in your list are 2s, 3s, and 4s.
Oh, yeah.
So, okay, so the first item through the 35th item are all a 2. And then the 36th item through, yeah, 75th are all 3. So that means your 51st and 52nd item in the list are both 3s. So that means your median is 3. Well, yeah, but you still have to, you can't just look, oh, 2, 3, 4, and 3 is the middle. You can't necessarily do it that way. Well, I mean, I could write down that that's like item number, the 76th item through the 102nd item. But I don't really, I mean, I already was able to, I don't need to necessarily go that far to know what my answer is, because I only needed to know what was item number 51 and 52. And once I know that, then I got the median. So, I mean, let's say just this one will be pretty fast. What if I said like, okay, here's, you know, I don't know, 5, 12, and 17. And let's say I have 100 of these and I have 2 of these and 20 of those. What do you think my median is going to be? I can pretty much see it right off the bat. What do you think my middle number is?
20.
So 100.
It's either, it's a 5, because I have a crap load of 5s and then some other numbers on the end. So my middle number is going to be 5. Because,
Oh, I see what you mean. Okay.
Is that-
Because like, it's like 20 and then the 2 below is a 20 in the middle. Okay.
but that's just the frequency. That's saying I have 100 5s written out, right? So imagine you've got 100 5s written out, and then you have 12 12, and then you have 20 17s on the end. So your middle number is going to be 5,
I see what
because you've got 122 items on your list. If you added those up, that'd be 122. If you did 122 divided by 2, it would be like, what, 61?
Yeah.
And then, so your median would equal the average of whatever is item number 61 and 62 on your list.
If it
And
was like 50 and 50, then it would be,
if your frequency was 50 and 50,
like, low of 50 and 17 and 50.
yeah, then it would probably be like the average between 5 and 12, or, yeah. If it was 50 and 50, then that would be 200, that'd be 100. So that, yeah, if you put it right on the line, that makes it a little bit trickier. You have to make sure you're doing it right. Let's see, let's do that. What if you had 50 and 50? So then you've got 200. So 200 divided by 2 equals 100. So my median equals, I got to take item number 100, 100th item, plus 101st item, divide by 2.
75 and 12.
So yeah, so you would do, so your 100th item is 5, and your next item is 12. So you would do 5 plus 12 divided by 2. 17 divided by 2, which is 8.5. Okay. All right, let me go ahead and give you your review.
Thank you.
Sure, of course, no problem. Okie dokie. So see you guys next week. We're nearing the end.
Is there anything you can do to make our grade better, like extra things?
Not really, no, but you know, the final exam grade can replace your lowest test grade, so that can help. And then, you know, just make sure that you're doing all of your homework.
So I missed a lot of homeworks, but if I still do them,
It depends on how late they are.
yeah.
If
they're
they
the ones from
will-
A couple weeks ago.
So yeah, if it's more than 10 days ago, then it's not going to improve your grade by doing them.
Okay.
So, But, you know, I would recommend like at the end of the semester, you can still go back and do them just to review for the final. That would probably help. Yeah, and just make sure that you do the review for the test. And, you know, you can always get help. You can come to my office, or you can go to the Academic Support Center and get help if you,
I understand the
help?
work mostly, like a lot of it. It's just that I forgot to do the homework, so I brought my grade down a lot.
yeah. That, it's overall, the homework grade, it's not going to make that big of a difference. As long as you can, I mean, if you can pass your test, you should be fine.
Okay.
Yeah.
Thank you.
Mhm.